Imagine a world plunged into darkness. Communication networks collapse. Essential services fail. This is not science fiction, but a possible reality, a powerful solar flare capable of crippling our technological civilization. The sun, giver of life, also holds the power to disrupt our world in unimaginable ways. How vulnerable are we to these solar storms? The answer is more unsettling than we might realize. We often think of natural disasters as earthly events, hurricanes, earthquakes, volcanic eruptions. But the greatest threat to our technologically reliant world may come from space, from the very star that sustains life on our planet. Solar flares, those sudden bursts of energy from the sun, have the potential to unleash chaos on a global scale, disrupting our way of life in ways we can barely comprehend. The sun, a churning ball of plasma, is a dynamic and volatile celestial body. Within its core, nuclear fusion reactions unleash tremendous energy, constantly shaping the solar landscape. Sunspots, cooler, darker regions on the sun's surface, are often the precursors to solar flares. These sunspots are associated with intense magnetic fields, which can twist and snap, releasing colossal amounts of energy in the form of solar flares. Imagine a rubber band stretched to its breaking point. The sudden snap, releasing all that stored energy, is akin to what happens during a solar flare. Charged particles, primarily electrons and protons, are accelerated to near the speed of light, hurtling through space in a massive burst of radiation. These solar flares can last for minutes or even hours, releasing an unimaginable amount of energy, equivalent to millions of hydrogen bombs exploding simultaneously. Earth, bathed in the sun's light and warmth, is also vulnerable to its occasional outbursts. When a solar flare erupts, a stream of charged particles, known as a coronal mass ejection, can be hurled towards our planet. Earth's magnetic field acts as a shield, deflecting most of these particles. However, a powerful coronal mass ejection can compress the magnetic field, causing geomagnetic storms. These geomagnetic storms can induce powerful currents in electrical grids, overloading transformers and causing widespread blackouts. Satellites, the backbone of our communication and navigation systems, are also vulnerable to damage or even complete failure. The delicate electronics in our increasingly interconnected world could be fried by the onslaught of charged particles, leading to a cascade of failures that could cripple our technological infrastructure. In 1859, the world witnessed the raw power of a solar storm. The Carrington event, named after the astronomer who observed it, remains the most powerful geomagnetic storm ever recorded. Telegraph systems, the cutting-edge technology of the time, went haywire, with operators reporting sparks flying from equipment and even receiving electric shocks. The northern lights, usually visible only at high latitudes, were observed as far south as Cuba and Hawaii. While the world in 1859 was far less reliant on technology, the Carrington event serves as a stark reminder of the sun's potential to disrupt our lives. If a similar event were to occur today, the consequences would be far more severe. The interconnectedness of our modern world, while a testament to our technological prowess, also makes us more vulnerable to the devastating effects of a powerful solar storm. Our world today runs on electricity. From power grids that deliver energy to our homes and businesses to the intricate network of satellites that enable global communication, our dependence on technology is undeniable. This reliance, however, is also our Achilles heel in the face of a powerful solar storm. A Carrington-level event today could have catastrophic consequences. Imagine a world without electricity for days, weeks, or even months. Communication networks would collapse, plunging the world into darkness and isolation. Financial transactions would grind to a halt, crippling the global economy. Hospitals, reliant on sophisticated equipment, would struggle to function. The very fabric of our society, woven together by the threads of technology, could unravel, leading to widespread chaos and disruption. The threat posed by solar flares is real and potentially catastrophic. Yet, it is not a reason for despair, but rather a call to action. By understanding the risks and investing in mitigation strategies, we can minimize the damage and ensure the resilience of our technological infrastructure. Space weather forecasting is crucial. By monitoring solar activity, we can predict solar flares and issue timely warnings, giving us time to take protective measures. Hardening our electrical grids, developing backup systems, and designing radiation-resistant satellites are just some of the steps we can take to mitigate the risks posed by solar storms. The future of our technological civilization may depend on our ability to prepare for the inevitable fury of our nearest star. If you found this information valuable, please subscribe to my channel for more insights on space and technology.